Welcome to solverfy.
Some weak acid, HA, partially dissociates into A- and H3O+, and this forms a buffer. If this buffer has a pH of 3.35, where the concentration of HA is 0.2 molar, and the concentration of A- 0.15 molar, we can calculate the pKa of HA using the Henderson-Hasselbalch equation. Rearranging this, we get pKa equals pH minus the log of the buffer component concentration ratio, which is the concentration of A- over the concentration of HA. So we can plug our numbers in here to get 3.35 minus the log of 0.15 over 0.2. This is 3.35 minus negative 0.1249, which is 3.4749. Let's say we add 0.0015 moles of NaOH to 0.5 liters of this buffer solution. We can calculate the concentration of NaOH since molarity is moles over liters. So we can divide 0.0015 moles by 0.5 liters and get 0.003 molar NaOH. The weak acid from the buffer will react with the hydroxide ions from the added NaOH to form water and conjugate base. Since hydroxide is a strong base, it will fully react with the weak acid, which is why this is a single forward arrow. So now we can set up an ice table. Initially, we have 0.2000 molar HA, 0.003 molar OH- from the added NaOH, and 0.1500 molar A-. Liquids aren't included in these calculations, so we can just ignore water here. To find the change, this is a complete reaction, so whatever can react on the left side will. So all of this OH- will react. So the change is going to be negative 0.003 molar. And since there's a 1-to-1 ratio of OH- to HA, we will react the same amount of the HA as the OH-, so minus 0.003 molar. And again, since there is a 1-to-1 ratio of OH- to A-, the amount of OH- that is being reacted is going to form that amount of A-. So the change here is plus 0.003 molar. The equilibrium, or the end, is then just the initial plus the change. So here, 0.1970 molar for HA, 0 molar for OH-, and 0.153 molar for A-. We now have these final concentrations of HA and A-, so we can solve for the final pH using the Henderson-Hasselbalch equation again. So here we plug in our previously calculated pKa, since that doesn't change. So 3.4749 plus the log of the new concentration of A-, So 0.1530 divided by the new concentration of HA, 0.1970. Some weak acid. This is 3.4749 minus 0.1098, which is equal to 3.3651. So with correct significant figures, this is 3.37. And just to double check, we started with a pH of 3.35 and ended with one of 3.37. That means the pH increased, which makes sense since we added base.